Trigonometry, Chapter 1, Trigonometric Functions, Section 2, Angle Relationships and Similar Triangles, Video 5, Similar Triangles. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the last video, we discussed congruent triangles. Recall that congruent triangles have the same shape and the same size. Excuse me, let me get a highlighter going here. We'll do the highlighter in blue. There are three pairs of congruent sides and three pairs of congruent angles, but in this video, we will discuss similar triangles. Similar triangles are two triangles that have the same shape, but not necessarily the same size. Each side on one triangle corresponds to one side on the other triangle. Each angle on one triangle corresponds to one angle on the other triangle. So we have the correspondence just like in congruent triangles. The symbol for similar is this tilde symbol, the little wavy sign. You might recognize it as the top part of the congruent symbol. It's not a coincidence. In this diagram, we would write triangle ABC is similar to triangle DEF. And again, notice the the order of corresponding points, excuse me. Like congruent triangles, the corresponding angles in similar triangles are congruent. So angles are congruent. This establishes the same shape criteria. In this pair of triangles, the corresponding angles are, I'm going to change the color of my highlighting. We'll do orange. The corresponding angles are A and D, indicated by the single arc, B and E, indicated by the double arc, and C and F, indicated by the triple arc. And all of those pairs are congruent. Concerning the sides, they are not necessarily congruent. If they were, the triangles would be both similar and congruent. All congruent triangles are similar, but not all similar triangles are congruent. The sides are proportional, which means that the ratio of two corresponding sides is equal for any pair of corresponding sides. For example, let's say I compared AB to DE. Little footnote there if you want to pause and read it. That's a ratio of corresponding sides, as is BC to EF or CA to DF. And in similar triangles, all three of those ratios would be equal to each other. Now, when we're comparing ratios, we almost always just use two of the three. And like with congruent triangles, we want to preserve the correspondence of points by writing segments in a consistent order. Now, to prove two triangles are similar, it's sufficient to show one of the following. Number one, two pairs of angles are congruent, or number two, all three pairs of sides are proportional. Now, normally, we will use congruent angle pairs to conclude proportional side pairs. It suffices to show two congruent angle pairs because it forces the third pair to also be congruent because of the sum of the angles in a triangle is always 180 degrees. For example, consider the following triangles. Why must they be similar? Find the missing sides. Well, the reason they're similar is that two pairs of angles are marked similarly. One pair is marked with one arc and another pair is marked with two arcs. Since two pairs of angles are congruent, the triangles must be similar. And because the triangles are similar, we can set up a proportion of any two ratios of corresponding sides. I should clarify that a proportion is an equation that equates two ratios. Now, because we can find only one side at a time, we must use a side pair that has no unknown values. That would be the two on the bottom, the 75 and the 25. So we're going to set up a ratio with those. But we also choose a side pair that contains an unknown value. Let's choose a pair that includes A, which is the pair of A and 10. And now we set up ratios comparing the sides of the first triangle to sides of the second triangle. 75 compared to 25 is equal to A compared to 10. And now we solve. Cross multiply, do 75 times 10 and 25 times A. 75 times 10 is 750. 25 times A is 25A. Divide both sides by 25 and you get A equals 30. Now we got to find B, so we're going to have to use its pair, B and 20. Using 75 and 25 again, 75 over 20 equals 75 over 25 equals B over 20. Cross multiply to get 1500 equals 25B. Divide both sides by 25 to get b equals 60. I know I went through the solving the equation quickly, but this is not an algebra class. You should be able to solve that equation. We get a equals 30 and b equals 60. Now, some of you might have noticed a trick. In some cases, you can determine the sides if you can spot a scaling factor for one pair of sides. For example, look at the bottom two sides. The bottom side on the left triangle is 3 times as long as the bottom side on the right triangle. Thus, the scaling factor is 3. The left triangle is 3 times as big as the right triangle. So we can multiply by 3 to go from the smaller to the larger, and that would instantly give us that A is 30 and B is 60. You can't always spot a scaling factor, but if they're similar, one exists. It might be a decimal or a fraction. One last comment. Sometimes it's tricky to set up the correct proportions because of how similar triangles are oriented. For example, what's the correct proportion here in this picture? Well, it'd be easier if we could rotate either triangle. So we're going to rotate the larger triangle, keep track of the x and the 9. There's the x, there's a 9. And the correct proportion is 4 over x equals 6 over 9. If we solved it, we would cross multiply to get 6x equals 36, divide by both sides to get x equals 6. So don't be afraid to reorient triangles to see the correct corresponding pairs. Now you try. Pause the video and try the following problems. Number 1, explain why the triangles are congruent, even though only one pair is marked congruent. And 2, set up the correct portion and find the value of m. Here is your warning. If you haven't solved it yet and want to, pause the video. Solutions in 3, 2, 1.